All right, we're back. This is part 2 of chapter 3 of the Managing Information Systems. We're talking about database management systems, which is a fundamental component of the Managing an Information System, MIS. We left off with logical database design, and we're talking about the data model. And the data model, when you hear that term and you need to define it or understand it, it's really talking about determining how data is collected, how it's created, how it's represented, organized, maintained, everything to do with data. And most managing information systems collect data. They can create data, they represent data, they organize data. So a managing information system is very closely tied to the data model. So it includes the data structure, which means what are you organizing, or what are you collecting? What kind of data are you collecting? How are you organizing it? What kind of connections and conditions and operations are you applying to those data? And also there's integrated integrity rules, which are you want to make sure that the data going into the system is going to be as clean as possible. It goes back to the GIGO. So if we don't have any integrity with our data going in, then we don't have any integrity going out. It's garbage in, garbage out. So the data model consists of those three key elements: the data structure, the operation, and the integrity rules. It's what they call, it forms the framework of the entire database management system. So it's a great quiz question when they ask, what are the three kind of key components, and describe a little bit of each one of them. Would be a great question. Now, part of the logical database design is looking at the different ways that we can structure these, how we can organize logically these databases. So one of them is called a hierarchy model. And a hierarchy model is this relationship between your records in a tree-like structure. It's kind of the older sequential, traditional way of organizing your data. And we'll have a look at some of those. The other type of logical design is a network model, which is connected like a network, where you're connecting different nodes or different data sets together, and you're creating relationships between them. There is a similarity between hierarchy models with how you can access the information and how it's organized, but it gives a little more flexibility. I always think of this as more almost like sequential data logical structures and random structures, similar to the previous video of sequential accessing and random access data. There's also a hierarchy model for each of those as well. So these kind of go together hand in hand. Here's some examples of what they would look like. Now, the first one here in the upper left-hand corner is a flat file model, which is pretty much the most basic, simplest type of data structure that you can have. It's just these are called columns, like a spreadsheet, and these are rows, which are called records, and individual data points collected together becomes a record of information. And these are, you can use a program like Microsoft Excel as a great program for keeping track of a flat file. It's like if you had a contact list and you wanted to know your contacts, their phone numbers, their emails, etc. That would be easily kept in a flat file. But once you get systems that need to have more complexity, then we need to look at other structures like the hierarchy model. And they call it a hierarchy model because it looks like it's in a hierarchy, where we have like one table of information, one data set. This is collecting a bunch of data on pavement improvement. That is connected to other data sets, like on the construction, maintenance of the pavement, and so on. And then the maintenance is broken down into the routine, and etc. So it depends on what how you want your data organized, and you're going to select which logical model you want. The network model is a little more, it's similar as you can see here to the hierarchy model, but it does rely more on relationships between tying the model, the data sets together. Relational models and object models have a similarity as well. And what they'd work on is having a table, okay, so like a flat file table. You can think of this as a table, and then this is another table. And you connect them together through a common data point, which they call a primary key and a foreign key, that connects them together. Now, the reason we want you guys to understand a bit about data structures is so that when you go into a company and you're collecting data, whatever job that you're working, if it's marketing, you're collecting customer information. If you're in human resources, you're obviously working with all the employees. If you're working in whatever other areas, you're going to collect data. So you need to know how the data is being collected, in what kind of structure, so that you can help better understand, to ask better questions of that managing information system. Now, Excel is a great tool for learning this, because if you've ever used Microsoft Excel, you know it's basically a two-dimensional table set up with rows and columns of data. And with inside there, and I don't have an example here on this sheet because I can't record Excel and this template at the same time. Unfortunately, I can't do that. So you might want to try opening up Excel and having a look at that. But anyway, rows are considered records, and the individual columns are fields. So if you think about Excel as ABC and then 1, 2, 3 down the sides, those are fields and records of information, which is basically a two-dimensional table of information. Columns, sometimes they call them attributes. I never use these terms of truples and attributes. I think there's a quiz question on these. You know, what's another name for records is a tuple, and what's another name for a field is attributes. But anyway, this is in your glossary, and I highly recommend you guys keep looking at your glossary terms, because a lot of those pop up in the quizzes. All right, the data dictionary. Now, it is kind of the metadata of the structure of how you're collecting your data. So, for example, if you're organizing a data structure that you're trying to collect maybe all your friends' names, well, some of the things you want to know is your friend's first name and last name. You want to collect maybe their birth date. So each of those have a very specific type of data that you're collecting. For example, their first name. You would want to have a validation rule or an integrity rule that only allows letters. And in fact, if it's a name, you'd have a capital letter in the first character and then lowercase letters for the rest. That would help the data entry person. It would also help the integrity of your data. Another example would be your birth date. Now, your birth date would be entered in as maybe a month, day, year. So you'd only have 6 characters, and you'd only have characters between a certain date range, because people probably wouldn't have been born before 1900, and you may want to project off into the future the next 70 years or so. So what that does is it prevents data integrity issues. It prevents that garbage from getting entered in. You probably have all experienced entering data into fields, and you just type in some garbage because they want you to fill it out. And as you type in garbage, sometimes it'll block you, say that's invalid. Like that happens a lot with email addresses. You got to have that @ symbol. You have to have a dot, and you have to have a character afterwards. Those are integrity rules that are applied to the data structure, which is part of your data dictionary. All right. So that kind of explains the structure behind your data base, and it helps maintain the data going in as being validated. Now, there's a couple other key compartments or components here to a relational model. Like the word says, relational means there's a relationship between two separate entities, two separate data sets. An example would be students at Douglas College. We've got a data set that keeps track of all of our students. And we have another data set with all the courses. Now, of course, the database with students, we're going to have tens of thousands of students at Douglas College. With courses, we might have thousands of courses. But they're kept in separate data structures. Now, we need to be able to tie them together. To tie them together, we need something what they call a primary key. And the primary key is a unique identifier that attached to the record to be able to selectively pull that person out or to flag them. And a perfect example is a student entered into our computer system has a unique identifier. Now, think about it before I tell you the answer here. What's your unique identifier at Douglas College? What uniquely identifies you? Well, you probably figured it out. It's your student number. No one else has that student number. Some people can have your first name and your last name, but no one will have your student number. In fact, if a lot of people have your first and last name, so what we do is we have your email set up with your last name and then the first initial of your first name, and then if there's somebody else with that initial, they add a 1. A lot of you might have the number 1 or 2 or 3 in your email address, and that's because people have the same initial, first name and last name. So I have that. My name is Caldwell R1 because there's Robert Caldwell at Douglas College and he has Caldwell R, and I don't get that. But I do have a unique employee number, just like you have a unique student number, and they call that the primary key. Now the foreign key is another key that we use to tie together these different data tables. It's a field in a relational table where there's two tables that are connected. That an example would be students and all of the student information connected with all of your course information, for example. So we can cross-reference these tables. Now here's an example of how that might look. So in this example here, we have a list of all of the, these are course IDs, and these are the names of the courses. So in this example, at Douglas College, we might have hundreds, if not maybe a couple thousand of different courses. Each course has a unique ID. That would be the primary key for this table. Now, if we wanted to connect all the courses with all the students, we have to set up a relationship. The relationship has to have a commonality, just like any relationship, right? Personal relationships, you need to have some commonality so that you can get along, so you can communicate. And that is the field. So we've got one here called the course ID. So within your student database, you got students ID, but you have their name, their last name, and all their other information. But you also have their course ID. What are they taking? What courses are they taking? So that course right here, the course ID is connected to the course ID here. So this would be the primary key for this data table connected to your student. And in the student table, they call that the foreign key, which one it's connected to. So the primary key and the foreign key, they both share the same name, but they're in different data sets, different data tables. Now, the concept of normalization is explained very well in the textbook, and I'm going to let you guys read up on it. There's a link on the PowerPoint slides here. You guys can go through and read a little bit more about that as well. But the bottom line between normalization, what I'll say, is it's to help reduce redundancy. And what they mean by redundancy is, for example, if you even looked at this other example back here, if I had students, a student record, let's say Jim, and Jim was taking 4 courses, I would have to put Jim in here 1, 2, 3, 4 times with 4 different course IDs. The concept of normalization is to break down data sets into compartmental blocks of data so that you don't have to repeat data. And that's what they call normalizing the data sets. And it's a process of taking larger data sets like this, breaking them down into smaller data sets so that there's no duplication. Essentially, that's what the process of normalization is to help eliminate or reduce data redundancy. All right. Now there is different stages of redundancy, and there's different different levels and for different types of data. So they've got what they call the first normal form all the way up to the 5th normal form of normalization. So I'll let you guys go through that in more detail, and I highly encourage you to read that chapter in the book because there will be questions on it, I think, on the quiz, and I think there's a question on the midterm on that one as well. So definitely do that. All right, let's get on to a relational model. Well, the fourth slide of the relational model is operations. So operations helps retrieve data from those tables. How do you retrieve data from tables? Well, there are some codes and commands, and if you're in the CSIS course and you're doing database level 1 and database 2 and SQL, you get into this in an extremely detailed amount on how to select tables or how to project or join together 2 separate tables to create a relationship, or where the intersection or union or differences. These are the kind of common operations terminology to connect these and set up relationships between these tables, which also helps in the normalization. All right, components of a database management system, slide 104. Okay, so there's database management components, and the key components are the engine, the data definition, the data manipulation, application generation, and the data administration. Wow, it's a lot to keep your heads wrapped around. So if you're choosing to do a career in data management, you would be you'd have to study, and each of these are almost like separate courses within their own. But at the introductory level of, this is a managing information systems course, and we want you to understand the basic kind of overall view of it. We don't want to get you into too much detail. But the database engine, is responsible for the data storage. How do you manipulate the data? How you retrieve the data? The data engine is responsible. It's the heart of the DBMS, is the database engine. So when you give it a question or a query, the database engine has to go back, look at the data, where is it stored, maybe you have to manipulate it, and then whether it's you've satisfied it and you can retrieve that information to get the report that you want. So the engine really interacts between the user and the database, and it can go out there and it says converts the logical request from the user. So you've actually put in some kind of request that you want the information to extract from there into that physical equivalence. Now, the data definition, which I've kind of explained a little already with the data dictionary, is to dig in further within the structure of how the databases are set up. And I think I've already explained it. Have a look at the link here. I think I put in some Wikipedia links in here to kind of expand. You should go in here and always click on this to find a little bit more of these, because I think they ask questions about, like, give me an example of a data dictionary, or can you explain what a data dictionary is? All right, so slide 3 here, the components, some more components, the data manipulation language. Now, within database management systems, there is a scripting, a programming language, and it's commonly referred to as the structured query language, or SQL. You'll hear that a lot when you're talking about database management systems. One of the primary manipulation languages is SQL. So it's like a programming language that you can use specifically for data structures to be able to add or delete, modify, retrieve records from the database. So when people want a report, management wants a report, they're going to make a report. They're going to say, okay, I would like to have a report that generates a certain type of record based on a certain criteria, and I want it outputted in a certain way. That can then be formulated using a data manipulation language, DML. So you don't really hear DML a lot, but you hear SQL a lot. And if you look for jobs under SQL, there are a lot of jobs. And I've worked with students and co-ops, and a lot of them are doing SQL work with database structures. So this is a good field, and it's a great field to be working in. It pays well, that's for sure. Application generator, again, is a component of a database management system. Designs elements so that the user can access and use the database. So this application generator is a tool that the programmers can use to help the user be able to integrate with the data. So most students, when they're using a managing information system, they use some kind of application generator to access the database. And I can give you an example of one of these here at Douglas. Unfortunately, I can't bring it up here, but if you go to the course scheduling tool in the Douglas College homepage, you can actually go in there and select your program, the course, even an instructor, because someone has developed an application to help generate that report. So it's designed to help the user access the database to get what you want. And this is really a large component of a managing an information system, is the application generation. The database components within most companies are so complicated that there needs to be protocols for data administration, how the data is going to be taken care of. So things that need to be taken care of are things like the backup of the data. Of course, if you lose your data, your company could be in jeopardy. So you want to know the backup and how you could recover it, who's going to secure it, what's the security protocols, where does it actually live physically within a geological location, are all very important topics when it comes to the data administration. Now, who does all that work? Well, the database administrator, they call them the DBA. If you Google a DBA and their job tasks, will actually incorporate in the course description or in the job descriptions what type of roles they're going to be doing, things like the backup and recovery and security, etc. So they're in charge of actually handling the database designs, the management, the output, and the overall everything to do with it. And at Douglas College, we actually have several people that work with the database administration because it's such a large component of the business. All right, now I'm going to, it's 20 minutes, so I'm going to call it at that, and we'll do another video on this one.